We are going to check today the last type of protection is the IPC system, impressed current cathodic protection. This is nice because until today we learn different procedures to protect the boat with different type of sacrificial anodes. But all of them are sacrificial anodes. All of them will be eroded at the end of the day and should be replaced to get the boat protected. No, but if you don't replace periodically those anodes, what happens?
So
It's not protected, no, and sooner or later the metals exposed to the direct contact with the water or the environment will be corroded, no. The sacrificial anode have an important role. This is one technique, and is a technique used today in the majority of the boats. However, there are a lot of big boats, containers, cheap containers, big vessels, with metallic structures, metallic hulls, aluminum hull, steel hull, and they prefer another technique. It's a technique used in the oil companies. You remember that in the oil companies, the oil is suctioned with the machines, and after that the oil is transported in pipes, in metallic pipes, long distances. No, for example, in the Gulf of Mexico, they have the refinery, not at the sea. Is 100 and something miles separated from the extraction. That distance is transported the oil in pipes, no? In pipes, and those pipes are in steel, special steel alloys. And but those pipes during the path are or could be affected for the environment, or could be affected for other external people interested to destroy the pipes and drain the oil. But one way to protect those pipes from corrosion, not from thieves, from corrosion, is with the system that I am going to explain today. Is the IPC, impressed current protection system. This is wonderful because it's a molecular theory to bombardier the structure with electrons and saturate the structures in order to complete a electron in the last orbit. When the structure is saturated, the structure will be protected. It's not affected for oxygen or nothing, no? Because the structure is perfect. Okay, this is the idea. Until today, we have this option, the sacrificial anode cathodic protection. This is an anode that is exposed to the environment, and the oxygen in the environment doesn't matter if it's the air or the water, attack the sacrificial anode, and the sacrificial anode will be eroded, and the structure, the metal, is protected. This is the idea, no? And we learned the procedure to select different type of sacrificial anode, depend of the metal, depend of the environment, depend of different situation, we select the sacrificial anode. This is the most common technique. The other technique, the second one, is the ICCP, impressed current cathodic protection, and that technique is very common in steam drive systems. Volvo Penta is, I think that the patent is Volvo Penta. All the Volvo Penta are coming with Mercathode, no? Yeah, the Mercathode is the ICCP system, and now we are going to analyze the Mercathode. It's nice. Okay, we are going to talk about the ICCP and what is the meaning of that. Suppose that this is the pipe. You see, this is the metallic pipe that transports the oil from the refinery, from the extraction area to the refinery. And those pipes are in some cases grounded, covered with sand on the ground, or in some places are elevated, exposed to the environment. Depend where is the area, but it's long distance, hundreds of miles with oil. in no also transport oil or transport gas, liquid gas, and also other products that is not only oil. Okay. The problem with those pipes is the corrosion, and this is the procedure used to protect those pipes. Pay attention. Those systems have this situation. This is the pipe. They have a rectifier. You remember the rectifier? The rectifier is the battery charger. No? And the rectifier receives AC power in one side and produce DC power. That's clear? Suppose that I have pipes from the ocean into Okeechobee Lake, for example. And if those pipes are pretty close to the towers with electricity, with AC power, I have AC power over there. I can introduce AC power in the rectifier, and in the output of the rectifier I have DC. And now I am going to use that DC to send electrons and bombardier the pipe. This is one way. Other way is with solar panel system. I collect the energy in group of batteries, and with a DC to DC converter, I send DC current. The deal is this: we need DC current, high amount of amps to bombardier the pipe and saturate the structure of the pipe with electrons. Everybody follow me? How can I get those high current DC circuits? From rectifiers, no? From DC to DC converters, no? I need DC current. Okay, this is the rectifier. The output of the rectifier is positive and negative. Okay, I connect the negative terminal of the rectifier volted on the into the pipe, and the negative enter in the anode, and the anode send electrons through the humidity and saturate the structure. The anode is not touching the pipe. The anode is separated. But with the humidity of the ground, the electricity flow and saturate the structure, the pipe. Anybody follow me? This is the ICCP system used in oil companies. And everybody understand what is the meaning of the rectifier? Rectifiers to convert AC current into DC or DC into DC. In what case the rectifier will be used to convert AC into DC? When the rectifier is close to the tower with AC power and enter AC and convert into DC. Or if that unit, the DC source of power, is a DC to DC. I have the solar panels. The solar panels collect in the battery, enter in the DC to DC, and the DC to DC send current to saturate the pipes. Everybody follow me? All right, this is the situation. This is the situation, guys. Look, those are the anodes, and the anodes send current and bombardier the structure and saturate the structure with electrons. Anybody follow me? What is the meaning of saturate? Complete a electron in the last orbit of that metal. When the metal is saturated with electron in the last orbit, how much is the maximum amount? 8. The metal is stable. It's stable. And if it's stable, react. If the metal is stable, can be eroded? No. Can be oxidized? No. The metal will be in great condition for long period of time. What is the inconvenience with that system? If the DC source of power stops. If the DC source of power stops, what happens with this flow of electrons? Stop. And the structure could be affected, no? For the environment. This is the inconvenience. You need to be 100% sure that you have a good source of DC, and in some cases you need backup. For emergency, If this one fails, the second one provides power, no? And this is the solution for marine applications. Okay, in the marine applications, if we are going to do the same process, we are going to install inside of the engine room the central unit. The central unit is a big rectifier that produces DC current. It's a big rectifier, and that rectifier send current to the anodes, to the reference cells, to the anodes, and the anodes saturate the structure with electrons, and the structure of the boat will be saturated. Yeah, this is the idea. Those anodes will be connected internally. This is the central unit, the central panel, and those are the anodes located in different places of the boat. The anodes should be replaced periodically? No. 15 years. It's a long period of time. The majority of the cargo ships, metallic structures, they use the ICCP system. They don't use the traditional sacrificial anode system. They use ICCP. Nice, no? Remember that the majority of those big containers, they have generators running constantly, and they rotate the generators 8 hours this, 8 hours this, 8 hours this, 8 hours this, and they rotate every day. And they have AC power constantly, but they have backup with the solar panels, the new systems. Nice, no? This is the system, and they have different anodes in different places. They have the central unit, the power unit, and the power unit provide power for the anode, supply current to the anode, and the anodes bombardier the structure with the electrons, and the structure is fully protected. And they have sensors in different part of the boat to monitor if the amount of electricity is flowing proper. Yeah, those are sensors, reference cells, and those are the anodes. The reference cells is to calibrate the output current coming from the source of power. Yeah, if the structure is ultra saturated, the reference sends the signal, and that power unit sends less amount of current to the anodes. Yeah, in order to keep the structures saturated until some point, because remember that you need avoid overprotection. You need avoid overprotection. What is the symptom when the structure is overprotected?
Paint starts coming off.
The paint is
Feeling.
yeah, the paint disappear. No, that's not good. To avoid that, you have the reference cells. The reference cells indicate and send signal to the computer here that reduce the current because the structure will be saturated. And this is another technique used in steam drive systems. Volvo Penta is a great example of the Cathodic. The Cathodic is this is basically the source of power that this is a DC to DC converter, because you connect here positive and negative coming from the battery, and from each output here, A and B, you connect two sensors, and those two sensors are located in the lower unit outside of the water. One sensor here, A, and the other sensor here, B, and those sensors impregnate with current the lower unit externally, and the lower unit and the block of the engine will be protected with those are the sensors, those are the anodes located outside, and those anodes emit current, and the current saturates the structure. You see, we have the Cathodic. One is connected with one sensor in the lower unit, the other one is connected with the other sensor, and in the middle the positive and the negative. And that's it. Sensor, and that system, simple system, saturate the steam drive system. It's very common in a steam drive system. What is the inconvenience with that Cathodic? Here, in this one, we have a positive and negative, position A and position B. for the sensors, for each sensor. And the positive and the negative is a constant positive and negative coming in. Constant power. Constant power. You need constant power in this DC to DC converter to supply power to the anodes. What is the inconvenience with that system?
Drains your battery.
Drain the batteries, number one. And number two, that if for some reason the DC system is disconnected in your boat or the batteries are drained, what happens with the unit?
Not protected.
Not protected and is corroded quickly. Yeah, you understand, my friend? But the number one issue is that this system drains the batteries too fast. But quick. Yeah, for that reason, you need to connect the source of power here, positive and negative in the boat, connected to the DC solar system to keep that system powered all the time, 100% sure, and avoid that the batteries be drained. Yeah, you need to connect the source of power here, positive and negative, to the bank of batteries that is charged constantly for different sources of power and additionally from the solar system. For example, a house battery bank. I don't recommend bring the power here from the cranking batteries. Yeah, I recommend here this source of power, positive and negative, from other group of batteries protected with solar system or charged with solar system. Yeah, that's the inconvenience. That's nice, no? This is the Cathodic. It's Volvo Penta. It's too simple. The connection is easy. You see that system commonly installed in steam drive systems. A steam drive system with gasoline engines or diesel engines, both of them, with both of them. Very, very, very common.